You're welcome to today's class. Today we're going to be doing a recap on everything we've done this week. The topic for this week is rational numbers and irrational numbers or non-rational numbers. Now I explained earlier on that rational numbers are numbers that can be expressed as a fraction. Then non-rational numbers are numbers that cannot be expressed as a fraction. An example of rational number is 6.2. 6.2 can be expressed as a fraction. This becomes what? 62 over 10. Also, every whole number is referred to as rational numbers because if I have 6 as a whole number, it can also be expressed as a fraction. It becomes 6 over 1. While non-rational numbers cannot be expressed as a fraction. An example is pi. Pi as a symbol is a non-rational number, but when changed to 22 over 7 or 3.142 becomes what? A rational number. We went on to explain how to express recurring decimals as rational numbers. Recurring decimals are decimals that keep on repeating itself till infinity. We want to express 6.25 as a rational number. If you notice there's a dot on 2 and 5, which means that this number can be written as 6.2525. It keeps on going. Now, to express this number as a rational number, I gave you 4 steps. The first step is to make y to be equal to this 6.2525, and you call this equation 1. The next step, to check the number of repetition, we'll have 2 repetitions, so we'll be multiplying by 100 because 100 has 2 zeros. So 100 times y will give me 100y. 6.2525 times 100, decimal point moves 2 steps forward, so we'll be having 625.25. You call this what? Equation 2. The next step is to what? Take equation 1 away from equation 2, or say equation 2 minus equation 1. 100 minus y will give me 99y. Now 625.25 minus, you must align your decimal point, 6.25. Don't bother about the rest because it keeps on repeating itself. So when you subtract this, 0, 0 point, 5 minus 6 not possible, you borrow 1 from this, becomes 15 minus 6 to give me 9, 1 comes down 6. So we then have 99y is equal to 619. Divide both sides by 99. This implies that y is equal to 619 over 99. Now, when you subtract, when you're done subtracting, and the answer you get, it's not a whole number, it becomes a big problem. You know that you have made a mistake from the beginning. So this subtraction helps us to arrive at a whole number. They will now make y the subject of formula. What about if you have a terminating decimal? Express 1.2 as rational number. This number is terminating. So this is like a more straightforward way of changing this. So if I have 1.2, now how many steps will I move to make this 1.2 a whole number? We'll move 1 step. So we'll have 12. Because I moved 1 step, I'll be having 10. This becomes what? The rational number. So if I have 6.25, without that dot, it means that this particular decimal is terminating. So to express this as a rational number, I move 2 steps. I have 625 all over what? 100 because I moved 2 steps. Now with this, I'm sure we've been able to cover up everything we've done on rational and non-rational numbers. If you have any question, we drop it. Thank you very much.